Greetings and salutations, all those nice things. Welcome to topic 6, where we're looking at relations and graphs. Now, you have seen some relations and graphs before in your previous years of study, looking at tables of values or coordinate points, placing them on grids, all sorts of cool stuff. And we're going to look at that a bit more closely, see how things are connected in this particular unit. And then this will segue nicely into the next unit where we look at very special types of relations. The first thing that I'd like you to do in this topic is consider the question on the next page. When we're considering the word set specifically as a noun, what words and phrases come to mind? Take a moment, discuss with the people around you. And again, specifically as a noun, not set as in to set down, that would be a verb, but as a thing, what is a set? What comes to mind when you think of what a set is? And again, discuss with those around you for a minute, write down some ideas, and then resume video. All right. In previous years, I've had a variety of things come up, but some of the most common ones I'm going to write down, and you can see if any of these match with what you've got. And if they add to what you have, then I would say write them down as well. If you've already got these written down, then good job. Super swell, splendid. Some people have referred to a set as a pairing or a grouping. I've also heard it referred to as a collection. These are from last year's class. Some members of last year's class, they said a pairing or group of things. One person said it's like a group, and another person said it's a collection of something. But these kind of general vibes, a grouping, a collection, that's what might come to mind when you think of set. As a noun, just standard English language, there's what it means. In mathematics, it means something very similar. So in math, we are talking about a collection or grouping of objects that share a common feature. A collection or grouping of objects that share a common feature. So there has to be some sort of distinct property that they have in common. And maybe you're grouping people by their hair color, or you're grouping animals by their genus, or, I don't know, stores by what demographic they cater to. But some sort of feature that they have in common. Numbers that all start with T. But some sort of grouping. An element of a set is a single object in the set. So where the set is a whole group, an element is just one of the objects in that group. It's like, here's my whole big collection of sports trophies from playing sports ball, and then this one element of the collection is this one soccer trophy from 1923 when I was 7. A relation is a connection between two sets. So how we link one set to another set. And there's many ways that relations can be illustrated for us. They can be described in words, so that's not really an illustration, that's just written. But we can also have tables, like tables of values, if you will, arrow diagrams, and sets of ordered pairs. 2 of these you've seen before. Arrow diagrams might be new, and that's okay if they are. We're going to go through what these look like. There you can also have some relations represented as graphs, and there's a number of ways to do that as well. You might recall from data analysis in grade 9, but also just plotting points on an XY plane. So those kinds of ideas will come into play here. For our first example, we're going to just, in table form, list some fruits and their colors. One fruit, one color per line. So in my table, I'll have a fruit in the left column, and I'll have its color in the right column. And we've got tons of options. There might be things that come to mind for you, but just for the sake of, I guess, consistency, uniformity, since I'm not there with you in person, and I do apologize for that, but let's just write down some things like, banana. And the color of a banana is yellow. What else is a good one? An orange. That has the color orange. We can also talk about, blueberries. I recognize there might be some debate about this, but overall I'd say that blueberries are blue. A tomato could be red. An apple could also be red, but wait, an apple could also be green. But wait, an apple could also be yellow. So here's some options. It's not every single fruit. It's not necessarily every single color that every single fruit could be in, but just some fruits, their colors. One fruit, one color per line. So each row has a single fruit and a single color. So one fruit, one color, no matter which line you're looking at. Even though apple occurred in here 3 times, had 3 different colors associated with it, each one got its own line in the table. And now we're going to represent this data with an arrow diagram. So as the description says on this previous page, an arrow diagram presents sets as 2 collections, each having its own elements enclosed, such as in a circle. And then each individual connection between the sets is represented by an arrow that connects an element in the first set to an element of the second set. So it references these individual connections, and the individual connections that we get from the table are the rows. So each row in the table represents a connection, and each one of those connections is going to be represented by an arrow in an arrow diagram. In this arrow diagram, we have our 2 sets. We'll have a set of fruits. We'll have a set of colors. And in the set of fruits, we'll just list every single distinct fruit we have. We have banana. We have orange. We have blueberries. We have tomato, and we have apple. Apple's only written once because apple and apple are the same thing. So everything in this set is distinct. So there's no 2 that are the same. That's one set. And we've even got it enclosed in a circle. So same. See if you can get the set of colors here. Write down what that should look like. And pause the video, resume, all that jazz. Hopefully you wrote yellow and orange and blue and red and green. Some of those occurred more than once, but they only got written once and enclosed in some sort of circle thing. Now, whenever we have an arrow diagram from header to header, we should indicate what the relationship is between the first set and the second set. So, a fruit is a certain color. That's kind of our description of the set. That's the connection between the first set and the second set. And then every single row in the table corresponds with an arrow in the arrow diagram. So where we had banana and yellow as a row, we're going to connect banana to yellow. Where we had orange to orange as a row, we're going to connect orange to orange. Where we had blueberries and blue as a row, blueberries connect to blue with an arrow. Tomato to red connects tomato to red. Apple to red connects apple to red. Apple to green connects apple to green. And then apple to yellow connects apple to yellow. And this is the complete arrow diagram. If you want to keep things tidy, then I would recommend using a ruler just to make all the arrows very easy to follow. This one's not so bad. We can kind of clearly see that there are 3 connections coming out of apple, and that there's only one coming out of all of the others. We can also see that there are 2 connections coming into yellow, and there's 2 connections coming into red, but only one into orange, one into blue, and one into green. So those are all the connections there. Finally, we're going to list these, we're going to represent this relation as a set of ordered pairs. When we have a set of any sort, it opens up with a curly bracket like that. This might take some practice to do. It's not like this. It's not like that. You kind of have to do a weird S out and then opposite S to come back in. That's how we open up the set. And then for the ordered pairs, each ordered pair is going to be in its own set of just round brackets like that. What goes in here? In the first spot will be whatever was in the first set for a connection, and the second spot is whatever's in the second set for that connection, where again, each connection is listed in this table. So banana yellow was a connection we had. So in this table, one of the ordered pairs is banana, comma, yellow. That's the first ordered pair. There's another ordered pair. There's however many rows we have, 1, 2, 3, 4, 5, 7 ordered pairs. And between each ordered pair, there's a comma as well. So note there's a comma here to separate what's first, what's second within the ordered pair. Right? The order matters. That's why they're ordered pair, because there's 2 things. And then because this is a whole list, it's a set, it's a collection, we're separating every item in the list with commas as well. So 2 different commas for 2 different purposes. Take a moment, see if you can complete this set of ordered pairs. And again, pause the video, resume, all that jazz. Alrighty. I'm going to finish this one off. You can compare, make sure you got the same. So I got orange, comma, orange as a connection. I also got blueberries, blue as a connection. I'm going to spill over to the next line. But note, I still put that comma in there, right? I'm not just ignoring it. It's still a list. Grammatically, this still makes sense. Next is tomato red. Then there was apple, which was connected to red. Apple and green. And finally, apple with yellow. Now to close this off, We finish off the ordered pair by putting in a closing bracket. We don't put another comma here because we've reached the end of the list. And because that closes out this set, this collection, we put a closing curly bracket at the end. And that is this one, D-U-N, done. All right, there are 2 more examples in this lesson, I believe. I'm mostly certain. So there's this thing with this table of shots that are seen in certain sports, and then something about natural numbers. Who knows what that's about? I dare you to give them a try. See how it goes. Give a good, honest effort. There's like a fair amount of space, so you can always put your guesswork somewhere. And then if that differs from what the video says that the answer is supposed to be, just have a record as to what you were thinking at a time, regardless. But again, pause the video, try them out, and then resume. All right, describing the relation in words. Provide a sentence that connects the first set to the second set in that order. So we see all these shots, and we see all these sports. And it looks to me that these are all shots that are seen in that particular sport. Phrasing-wise, because we have to have the first set, then the second set, we're not going to say something like a sport has a certain shot, because that has sport first and shot second. So that's a big no. We do have to have it in the order. We can say something like a shot is used in a certain sport. And that would be a connection. As an arrow diagram, the shots we had involved were serve and block, drop shot, dump, spike, and smash. And the sports were just volleyball, tennis, and badminton. And the connections that happen in there, serve connected to all 3 of these. Block connected to 2. Drop shot was a tennis and badminton thing. A dump was just connected to volleyball and badminton. A spike was only connected to volleyball. And then smash was seen in both tennis and badminton. And then, of course, we do need to state what the connection is to get from the first set to the second. And that's our description. That one is done. Let's state a set of at least 4 ordered pairs belonging to the relation. So I would probably typically just go with whatever the first 4 I see are. So I've got serve, volleyball, serve, badminton, serve, tennis, block, badminton. If I put those as ordered pairs, that's enough. But I can really state any 4 I want. I can go serve, volleyball. I could go block, badminton, drop shot, tennis, smash, tennis, if I want. Just any 4. And whatever 4 you picked, as long as they are 4 that correspond with rows in that table or arrows in this arrow diagram, then you're A-okay. Let's go serve, volleyball. Let's go block, badminton. Let's go dump, badminton. And, oh, running out of room. Gonna go to the next line. You're right, let's get some tennis representation in here. And then once again, closing out the set with a nice curly bracket. That is that one. Last example here. Ooh, we're told that a natural number is spelled with how many letters? A natural number of letters. So this is kind of like, 3 is T-H-R-E-E, so that's 5 letters. Or 6 is X-S-I-X, and that's 3 letters. So that's what's going on here. Erase. Nailed it. So describing the relation in words is pretty much using this exact same phrasing here. A natural number is spelled with some number of letters, a natural number of letters. And you might have something similar, or you might have the same thing verbatim, in which case neat, but if not, that's all right. State a set of at least 4 ordered pairs belonging to the relation. Who knows what you came up with? There's infinitely many options here. I would say the number 1 is spelled with 3 letters. The number, 7 is spelled with 5 letters. And the number, it's a good one these days. 4 is spelled with 4 letters. And, I don't know. Let's go 2. And that's spelled with 3 letters. It says at least 4. We can get one more in there. Let's get 3, which is spelled with 5 letters. So that's that. And then last thing is to provide a table of values that lists at least 4 connections in the relation. So we'll have a natural number, and the other column will have a natural number, which shows just what we have in like our first ordered pair is 1, 3. So 1, 3 is a row in this table. Then there's 7, 5. So 7, 5. I next had 4, 4. So I'll put 4, 4. I next had 2, 3. So 2, 3 goes in here, and then 3, 5 was my last one. Yours might look slightly different depending entirely on what ordered pairs you put in here. And that's okay, as long as whatever you've got for the table corresponds with whatever you listed for these ordered pairs. And you can have someone next to you double check it, verify, talk it through if you want. That's okay. Anyways, please work on the practice work. I think that's the end of this lesson. So work on the practice work, see how it goes. And I will see you soon. Peace out.